Now let us talk about the coating material for strain gauge. You know the principles of strain gauge. It works by measuring changes in resistance in order to quantify the strength experienced by the test specimen. The measurement will be valid only when the resistance in strain gauge is extremely stable. Any changes in terms of the conditions of the strain gauge may lead to changes in the resistance. Even though there is no strength, the measured value end up to be with strength. This leads to inaccurate measurements by the strain gauge. Therefore, by all means, we need to protect the strain gauge as well as the lead wires from various environmental factors that could affect the measurements. Now the question is, how do we protect the strain gauge from the environmental factors? This leads to the coating material that we're going to discuss in this video. First, we need to know the characteristic as required from this coating material for strain gauges. The coating material need to have excellent resistance to moisture and water, and it should be a good electrical insulator. This is to prevent the noise or disturbance to the measurements of the strength given by the strain gauge. Next, the coating material should have a good adhesion to the strain gauge, lead wires, as well as the test specimen. Once it is laid over the strain gauge, it isolates the strain gauge from the water, provide insulations to electric, and remain there as long as it is required. A good adhesion to the strain gauge is required. Next, the coating material should cause no constrictions to the test specimen. It means that it causes no pressure or shrinking to the test specimen. Some test specimens may be sensitive to the pressure. By having this coating material lay over the test specimen while shrinking, the coating material induces pressure to the test specimen, and this leads to the undesired change of strength within the test specimen as well as the strain gauge. Next, let us look at the effects of moisture on strain gauge. You know that the strain gauge is very sensitive to moisture. When the moisture is absorbed by the strain gauge and the adhesive, there will be changes in terms of the gauge resistance. These changes is undesired, as these changes of gauge resistance is not due to the deformations of the test specimen. Now the measurements of the strength will be based on the changes of the gauge resistance. You will need to prevent moisture from contacting with the strain gauge and adhesive. Secondly, the absorption of moisture by the strain gauge may result in corrosions of the sensitive element. You know that the sensitive elements are made of metal, and this sensitive element is used to conduct electricity, and when corrosions happens on this sensitive element, there will be changes of the resistance. These changes of resistance does not reflect the actual deformations of the test specimen. So, by all means, it should be avoided. Next, absorptions of moisture by the strain gauge result in lower insulation resistance. You know that due to the mineral in moisture, electricity may be conducted. Now, when there is conducting of electricity, the measurements of the strain gauge may not be accurate. Next, we look at the classifications of the coating. There are two main categories. The first one is for chemical protections, and the second one it will be for the mechanical protection. The meaning of mechanical protection is referring to the physical protections, such as abrasions, pressures, and others. As for the chemical protection, There are protection against moisture or water, protection against oil, protection against low temperature, and protection against high temperature. The relevant coatings are listed here. The coating material W1, Eng-aim, SB10, and etc. are used to protect strain gauge against moisture or water. There are others. Now this coating material looks similar in terms of the package as well as in terms of the products. Before you use, make sure you read the labels. Next, we talk about the coating application methods. First is the hot melted method. The relevant coating, it will be W1. This coating becomes liquid when heated and solidifies when cooled. It has excellent resistance to moisture and water and is the most widely used coating. The second type, it will be air drying rubber solvent. This will include N1 and K1 coating. This coating can be brushed on and allowed to dry. They are flexible when dry and have no constrictive effects on the test specimen. And then we have pressure sensitive rubber. This includes SB tag and VM tag. These coatings are applied by being pressed onto the test specimen. It provides excellent resistance to moisture and water, and it is easy to use. The last type, it will be coating tag for reinforcing bar. This will be the CT tag. It is a specialized coating for use on reinforcing bar embedded in concrete and can be applied quickly. These are some of the products that you can see. This is SB tag, W1, UE1, and VM tag. Another considerations for selecting suitable coating, it will be based on the operational environment. There are 4 main categories, which include atmosphere, high or low temperature, underwater, high temperature, under pressure, water pressure, or oil and other special substance. We're going to look into it one by one. First is about the atmosphere. It can be further classified into indoor and outdoor. For indoor, the purpose is mainly for the moisture protection. Then you may use single layer coating such as W1, N1 or SB tag. A single layer coating should be sufficient. Now if you're dealing with outdoor testing, you may need protections against water, rust, and other mechanical factors. Under such circumstances, you may require more than 1 layer coating, which your W1 should be combined with mechanically protective coating in order to prevent corrosions and particularly rusting. W1 is mainly to protect against the moisture and water. Probably you may consider to provide some mechanical protections for the outdoor testing, depending on the situations. As for the testing underwater, there are 2 categories also. This includes freshwater and seawater. If you are testing under freshwater, your ultimate goal here is merely to do some waterproofing. You may use W1 up to 60 degrees Celsius and SB tag up to 80 degrees Celsius. What you see here, different type of coating material has different applicable range in terms of the temperature. And if you are testing under seawater, it is not just the moisture that you need to prevent. You may need to prevent the minerals as well as the chemical attacks. In that case, you will need to do protection against water, rust, and mechanical factors. You will need to use an anti-corrosive coating for use with seawater, and you may require the protection against mechanical factors, particularly protection against the current flow. This again will have to be depending on the situation. However, to be safe, since that you are testing the specimen under high temperature, there may be current flow due to the heat. To be safe, you provide protections as necessary. Next, if you are testing the specimen under pressure, particularly water pressure, then you will need to do some waterproofing. You may require flexible coating to ensure that no air bubble forms under the coating and that the pressure is uniformly distributed over the strain gauge. Next is about the oil and other special substances. Your purpose now is to maintain the insulation's resistance as well as protection against corrosions. You might need to also look into the heat resistance of the lead wire insulation's material, as this may also affect the results.